Hello, in this video I'm going to work on a few more problems when it comes to being given a linear equation and having to find where that line intersects with a quadratic. And so, for example, the first question I have here in front of me, we're given that it states to find the coordinates of the points at which the line with equation y equals x minus 4, y equals x minus 4, intersects the curve with equation y squared equals 2x squared minus 17. And so basically, yeah, we want to find where this line intersects the curve. Already, equation 1 is written quite neatly for us, where it's y equals x minus 4. I mean, we could rewrite this if we wanted to and have it set to x equals y plus 4, and then substitute that into the second equation. But we'll just keep it this way, y equals x minus 4. We're going to use the method of substitution. We have, of course, two unknown variables here, x and y, so that's why we're going to set up a system of equations, or in other words, use solve simultaneous equations. And so yeah, we're going to substitute y equals x minus 4 into equation 2. And so we have in equation 2 y squared. Well, we know y equals x minus 4, so it's x minus 4 squared, and now that's going to equal 2x squared minus 17, and we just have to FOIL this out on the left hand side. So it'll be x minus 4, and that's going to be set to equal to 2x squared minus 17. Okay, so we're just going to FOIL this out, or use the distributive property twice, however one wants to think about it. And so in that sense, we have x times x, and I won't go through it all, so we just have x squared, x times negative 4 is minus 4x, minus 4 times x, again, minus 4x, and then we have negative 4 times negative 4 plus 16. All that set to equal 2x squared minus 17, and we can simplify our 2x terms, negative 8x. And now the best way to arrange this actually would be to just subtract x squared from both sides, add a x to both sides, and subtract negative 16 from both sides. And it's just going to rearrange it, in other words. And so what we have then is, if you have 2x squared and you subtract an x squared, you're left with x squared plus 8x. And then minus 17 minus 16, that's going to be 15 is 30, so it's going to be 1 and 3, 2, so it's minus 33. Right, so we're left basically with a fairly healthy quadratic. Looks a little bit awkward, but should be okay to factorize. We just need to solve for x, find our two values for x, and we can substitute them back into our first equation 1 and get our corresponding y values. So we need to find AC first in order to continue the process of factorization, which is going to be a is 1, c is negative 33, so c is negative 33. So now we need to find what multiplies the negative 33 and adds the positive 8. And the first thing that comes to my mind is 3 and 11. 3 times 11 is clearly 33, and we need it to add to 8. So if we make this 3 negative, 11 minus 3 is 8. So we've got our two factors here, and that of course will equal negative 33. Also, if we multiply negative 3 by 11. Okay, so we've got our two factors, so we'll rewrite this as x squared minus 3x plus 11x minus 33, all that set to equal 0. And now we can factor out an x here, so it's x minus 3, and we can factor out an 11, and so we're left with x minus 3, and therefore we have x minus 3 and x plus 11, and therefore x is going to equal 3, and or x x is going to equal negative 11. So we're almost done. We just now need to substitute these values of x back into equation 1 to find the corresponding y values, and we will have the coordinates for the point of the 2 points of intersection where the line meets the curve. So when I'll write it up here, when x equals 3, y equals 3 minus 4, which of course is negative 1. So y equals negative 1 when x equals 3. I'll just box that off. It's a bit messy, but that will do. Now when x equals negative 11, y equals negative 11 minus 4, which is going to give us negative 15. So the 2 points of intersection are going to be 3 and negative 1, and negative 11 and negative 15. And for your plot to graph, you would find that this is where the line meets the curve at these 2 points.